Let us discuss about the transformer. The transformer is an electrical device that transfers electrical energy from one circuit to another circuit without any actual contact. So, what is the construction of the transformer? In the transformer, we have got two coils. One is called as the primary coil and another is called as a secondary coil. Those coils are wound on a laminated soft iron core, but those are insulated from the soft iron core. What happens? One coil, mainly the primary, is charged by an AC source. When the AC current flows in the primary coil, the AC is changing, so it produces a magnetic field, and that magnetic field linked with this coil changes. And that flux, that changing flux, is channelized through the laminated core to this secondary coil. In this secondary coil, when the flux linked with the secondary coil changes, an EMF is induced in it, and that EMF produces the current in the load, where this is the load resistor. So there is no direct contact. What happens? This transformer works on the principle of the mutual induction. That means the flux that is changing with this coil NP is linked through the laminated or the soft iron core to this secondary coil, and that changing flux in that secondary coil produces an EMF, and the current is induced in this resistor when the resistor is connected to the two ends of the secondary coil. This is the basis of the transformer. The transformer is the most efficient electrical machine because it has not got the moving parts, so the efficiency of the transformer is up to 97%, and by some intelligent designs the efficiency goes up to the 100%. Let us discuss about the working of the transformer. Now let phi be the flux produced by the AC, phi be the flux produced by AC, and NP be number of coils in primary, NS be number of coils in secondary. Let phi P be the flux linked with the primary. That will be equal to number of turns of the primary, magnetic flux phi B, and A is the area of the coil. Similarly, phi S be the flux linked with the secondary. That is equal to NS phi B into A. EP be the EMF in the primary, and that is equal to the rate of change of the magnetic flux that is linked with the primary. That is equal to minus d phi P divided by dt. That is equal to minus d by dt of NP into phi B into A. And that EP equals to minus times NP into A, being a constant, is taken out of the differential sign, d by dt of phi B. Similarly, ES is given as minus NS into A d by dt of phi B. Now taking the ratio and assuming that all the flux that is linked with the primary is channelized to the secondary, that means the rate of change of flux with the primary is equal to the rate of change of flux with the secondary. So we have that taking the ratio, that is ES divided by EP, will be equal to minus times NS into A d phi B divided by dt divided by minus NP into A d phi B divided by dt. And here we can say that as the area is same, A gets cancelled, d phi B by dt gets cancelled, and minus gets cancelled. So we have ES divided by EP is equal to NS divided by NP, where ES is the EMF in the secondary and EP is the EMF in the primary, NS being the number of turns in the secondary and NP being the number of turns in the primary. Now we have that this ES by EP is called as transformation ratio, that is equal to K. So K is equal to NS divided by NP, or more efficiently it is the ratio of EMF in the secondary to the EMF in the primary. This is called as transformation ratio. This K is called as transformation ratio. We have also another ratio that is called as Turner's ratio. Please remember Turner's ratio. Turner's ratio is the ratio of number of turns of the primary to the number of turns of the secondary. Here we can say that transformation ratio is the number of turns of the secondary to the number of turns of the primary. The Turner's ratio is its inverse. The Turner's ratio is equal to number of turns in the primary to the number of turns in the secondary. Now, depending upon the value of the K can be greater than 1, K can be less than 1 and K can be equal to 1. We can see by these examples. In this we have got transformation ratio, that is K is greater than 1 because the number of turns in the secondary are greater than the number of turns in the primary. If K is greater than 1, we can easily see that ES should be greater than EP. So EMF in the secondary coil should be greater than EMF in the primary coil. This type of transformer is called as step-up transformer. Step-up transformer. Now in this we can clearly see that K is less than 1. If K is less than 1, that means the number of turns in the secondary is less than the number of turns in the primary. That means here we have ES is less than EP. So the primary voltage is greater than the secondary voltage, or the secondary voltage is less than the primary voltage. This means this type of transformer is called as step-down transformer. Step-down transformer. We have also got transformers where K is equal to 1. Where K is equal to 1. Here we have is 1:1 transformer. And what is the benefit of this transformer? This transformer acts as a filter for DC. That means we have that the transformer works only on AC. If we have got an input that has got the components of DC as well as AC, when we connect it as an input to a transformer, the transformer only works on the AC and blocks the DC content. That means this transformer, which has got the K equal to 1, that means that has got the turns ratio as well as the transformer ratio equal to 1, that acts as a filter for DC components that will transmit AC only. Now the thing to think is that how is the transformer able to set up the voltage and set up down the voltage? It cannot create energy, it just transmits energy from primary coil to secondary coil. It cannot create energy because energy can neither be created nor be destroyed but can change from one forum to another forum. Here the transformer works on a principle that input power is equal to output power. Input power is equal to output power. That means the input power is equal to input voltage, that is primary voltage IP, into input current, that is primary current. Here we have secondary current and secondary voltage. We have that ES divided by EP, that is equal to the transformation ratio K, that is equal to IP divided by IS. That is equal to IP divided by IS. This means that when we are having a step-up transformer like this, when we are having a step-up transformer, it increases the voltage or the EMF on the cost of lowering down the current. That means when we have a step-up transformer, it steps up the voltage but steps down the current. And when we have a step-down transformer, that steps down the EMF on the cost of increasing the current. That means when we have got the secondary voltage that is less than the primary voltage, but the secondary current is more than the primary current in case of a step-down transformer. That is got from the input power is equal to output power. So we can say that the transformation ratio is the ratio of EMF of the secondary to the EMF of the primary, or current of the primary to the current of the secondary. This is the working of the transformer. Now in a transformer we have got minimal losses, that is like 3% of the loss, and those 3% of the losses are categorized into I square R losses and eddy current losses. What are I square R losses? I square R losses are due to the presence of the resistance of the two coils. When the current flows in the coils, heat is produced as per Joule's law of heating, that is H is equal to I square RT, and those losses are called as I square R losses. Those losses occur in the coils of the transformer. And another thing is that when we are having a core and the core is of soft iron, when the flux linked with the core changes, the currents are produced or the currents are induced in that soft iron core, and those currents are called as eddy currents, and by those eddy currents we have got eddy current losses. Those eddy current losses are minimized by having a laminated core, and those laminate or those strips of the laminated core are separated from each other or insulated from each other by a film of the varnish. So by using a laminated core, we can bring down the eddy current loss, and we bring down the eddy current losses by using the laminated core. This was all about the transformer. Hope you enjoyed. Thank you.